Hey guys, this tutorial is going to show you how to add your own custom hotkeys to the editor. So if I go to editor preferences here and keyboard shortcuts and I search custom, you can see I've added a custom command here with the hotkey Shift F. And just as an example, I've implemented the ability to snap spline points together. If I hit Shift F, you see it snaps right to the nearest spline point in the editor. Again, just as an example, you can use this functionality to hotkey whatever you want in the editor. To get started, I have a empty project here, just on the usual tutorial map, and we're going to go into plugins and just create a quick plugin for our code here. So I'm going to click add on the top left here. We're going to make a blank plugin, and the name of this is just going to be custom hotkey switcher, and just add some of the other information here. So we're going to have it implement a custom hotkey that does stuff in our project. Okay, and we'll hit create plugin. And once that's done, we can close down our editor. And back in VS Code or Visual Studio here in our plugins folder, you see we have a custom hotkey switcher folder now. And so first we're just going to add the basic hotkey support. So if you go into source and open the build file, we're going to need a couple of dependencies here. The first one is going to be input core, and we're going to need Unreal Editor as well. So then if you go to public custom hotkey switcher.h, this is our module class. So we're going to need a couple things here. First, let's just make a method that we want to call when you press the hotkey. So void on custom command, and you can make this whatever you want, name it whatever you want. And then for a member variable, we're going to want a place to store the command info. This will include things like the default keystroke that you want to press to activate the command. So this is going to be a t shared pointer to a forward declared FUI command info. We'll just call that custom command info equals null pointer. And then switching over to the CPP file, we just have all the default stuff here. So we'll start just by implementing that method that we just made. So void f custom hotkey switcher module. What do we call it? On custom command. Okay. And for the moment, we'll just log something. So we're going to need a log category at the top here. And we'll just do define log category static custom hotkey switcher module sub log all. And then in our on custom command, we'll just UE log, use our log category that we just defined up there, display, and we'll just log on custom command so that we can see that it happened. And then in startup module is where we're going to actually attach our custom hotkey, but we're going to need a few includes first. So at the top, we're going to need interfaces / I mainframe module. So this is the representation of sort of the main window of the app, and all the other windows are launched as childs of this, or children of this, I should say. We're also going to need editor, Unreal Editor Engine. We'll talk about that in a second. We're going to need the Unreal Editor globals.h. There's a few global variables for the editor that we'll need to pull in. And we're going to need engine utils. We're going to need limits. Not that important, but you'll see what that's for later. And we're going to need framework / commands / input binding manager.h. And this is the key class we're going to add our bindings to. So then down in startup module, we can just delete that comment for now. And first thing we're going to need is the binding manager. So f input binding manager, and it's a reference input binding manager, and f input binding manager get. You get that reference. And then we're going to need that mainframe module we included. So mainframe module equals I mainframe module get. And then we're going to need a shared ref to an FUI command list. And this is the command list we're going to add our hotkey to. So the mainframe module has a list of commands that apply to its context. And if you've ever added hotkeys to another thing, like maybe you made a custom window in Slate that you launched, You'd probably have your own command list that applies to that Windows context, so it's only applicable when the window's up. In this case, we want it to be a somewhat global hotkey that applies anywhere. And so we're going to add it to the mainframe modules command list, and we get that by doing mainframe module.get mainframe command bindings. And if we look into what this is, you can see that it returns this fmain commands or fmainframe commands action list. We can look at what that is, and this extends t commands. So you can see these are all the commands that can be done on mainframe, and we're basically just going to add one more of these. That's where the shared pointer FUI command info we declared in our modules header file, what that's going to be used for. And typically, register commands is called or overridden to register all of these commands. And if I look in the CPP file for this and we look at register commands, you can see it uses this UI command macro to register all of these. And if I go into that, which is in commands.h, you can see there's actually two macros here. One is regular UI command, the other one is UI command extended. So we're actually going to use the extended one so that we can add to the existing command list for this mainframe. And so let's go back to our custom hotkey switcher.cpp file. And in order to add to that context, first we need to get the context. So we're going to say fname mainframe context name equals text mainframe. And if I look at that mainframe actions, the way you know what the name you want is in the constructor of that tcommands class that it's extending. It's going to pass mainframe here. So this is the text we're going to use. Unfortunately, this is in a private module, so we can't just include it. So we have to duplicate that. And then to get the context, we'll do t shared pointer, f binding context, mainframe context equals input binding manager dot get context by name mainframe context name. So we use a binding manager to get the context by that name. And then we're also going to need the chord that we want as the default. So we're going to make an f input chord default input chord. And we'll just give it, let's say shift F is what we want this to be. So E modifier key shift, and then E keys F. So you hit shift F and that'll be the default key, and you'll be able to change it in the editor later. I'll show you how to do that as well, but that'll be the default. And then we're going to do UI command extended mainframe context.get. It needs the custom command info. This was in the header, this thing that we just defined before. That's where it's going to put the result of this. And we need to give it a name, so custom command 1, let's say. And then we got to give it the user-facing friendly name, so custom command 1. And by the way, for this to work, we actually need a you need this loc text namespace defined, so the module automatically makes one, so it'll find it. But if you get an error, just know this needs to exist. And then the description for it, we'll say custom command and user interface action type. It's going to be a button. And we need to give it the default input chord that we defined above here, right there. That's good. That defines it and creates the custom command info that we need. So now we just need to map it to the context. So the context was this mainframe context. So we're going to do mainframe, or excuse me, we need to map it to the command list. So we've added it to the context. Context has this list of commands, and we're going to map our new command now. So command list map action, and we're going to give it the custom command info, and we're going to give it the action to run. So f execute action, create raw, and it's in this class, and it's f custom hotkey switcher module on custom command. And again, this is the method that we created below, and all it's going to do is log this out. Looks like I missed a colon there as well. Yeah, so it's just going to log on custom command whenever our default chord at the moment is pressed, shift F. Now, you have to be sure that there's no conflicts here because it's going to take the first command that has this chord. And I happen to know that shift F already has a conflict, so You could go into the editor and just find that and remove it. You could search to see which one's using it, but the easiest way is probably just do this automatically. And so we're going to search for conflicts and remove any if they exist. So in order to see if anybody else is using that chord, we can do const t shared pointer for FUI command info. We'll just call this existing command. And we'll set that to input binding manager.get command info from input chord. And we give it the context we're looking at, mainframe context name. Give it the default input chord. And the last argument needs to be false. And this is just if we want to check the default or the currently set one. And we want to check the currently set one, not the default. So then if that returns non-null, so if existing command dot is valid, and we also want to make sure it's not the chord that we just set. So if the existing command is not equal to custom command info, so it didn't return the one that we're setting, then we want to just clear it. Now you could check which, you can set 2 different hotkeys for each command. You could check which one it is, but we'll just remove both. So existing command, remove active chord, key multiple, key binding, index primary, and we'll remove the secondary one as well. So once again, primary is the first key that you assign to the command, secondary is the second key. We'll just remove both if there's a conflict. And that should be all we need to do. So now we can build and run. Now in our editor, if I bring up our output log and I clear that, if I hit Shift F, you'll see that on custom command gets displayed. And this will work anywhere in the editor as long as something else doesn't eat it. So like if I go to my content folder and I open some other blueprint file here, and if I hit Shift F here as well, you can see that it still shows up as long as it's not eaten. You'll notice if I click on console command and hit Shift F, it is not hitting my command because it's being eaten by this text box to write F instead. Okay, so we can close this window. And I mentioned you can also change the hotkey binding here as well. So if I open my editor preferences and go to keyboard shortcuts, I can search for custom, and you'll see under mainframe context, there's a custom command 1 with the a custom command description we gave it. You can see Shift F is the current default. We can reset it if we want, if we wanted to change it there. But yeah, so that's how you set a custom keybind. Now let's say you actually wanted to do something useful with this Keypress. So this I actually had a recent example where I wanted to snap spline points to other spline points in the scene. So let's recreate that real quick. I'm going to make a blueprint called BP spline. And I'm going to open that up and just going to add a spline component to this root here. Here we go. And I'm just going to change the color of the spline points to be a little bit more visible. So we'll make those red. And you can see if I add these, I'm going to go to my top view. I'm going to add a couple splines here. So let's say that I want to be able to take this point, and if I move it here and hit Shift F, I want it to snap to this other point right here so that they're perfectly aligned. So that's what we're going to do. So let's save this real quick and close the editor. And first thing we want to do is if we go to our build.cs file, we're going to use what's called a component visualizer. So when Unreal Editor draws the handles for those splines, those are drawn using what's called a component visualizer, and there's a package called component visualizers that we want to include. So put that in your build file, and then we're going to go to the CPP file. And at the top, we're going to need a couple things here. We're going to need the Spline component visualizer .h, and we're going to need the spline component. So component slash spline component. That should be it for the includes. And then we're going to go down to our custom command method here, and we're going to make it actually do something useful. So first thing we want to do is make it a shared pointer to our component visualizer. So f component visualizer. Visualizer. And this is where the Unreal Editor globals come in. So G Unreal Editor Spline Component Visualizer, view Spline Component, static class. So this is going to get the visualizers that are used for Spline component classes. And then we want t-shared pointer f spline component visualizer, spline visualizer. So this will get the more specific static cast shared pointer f spline component visualizer. So we're going to get the visualizer for the spline component class, and we're going to cast it to the more specific f spline component visualizer here. And then if you spline component equals spline visualizer get edited spline component. So if there's one being edited, we're going to put it in spline component. And we want to get all the other spline components in the world that are not this one. And if your level is going to have a bunch of these, so if your level is going to have a ton of them, you could sort them by location in an octree or something. So just putting a note here that this, we're just going to sort of iterate over everything in a slow and dumb way. But if you had performance issues, you could sort all of your spline components ahead of time into an octree or something, and it would make it, O of n log n instead of O of n squared like we're about to do. But for any reasonable number of spline points in your level, you're not going to notice, so it's not worth the effort. So first of all, we're going to find all the other splines. So we're going to make an array called uSpline component, other splines, and we need our world for the editor. So uWorld editor world is spline component. Oops, get world. And then we're going to iterate over all the actors. So t actor iterator, actor itr, and we'll give it the editor world and actor itr doesn't need to change here, and plus plus actor itr. So we're going to get t array of u spline components. And we're going to say actor itr get components u spline component. So for every component in this actor, we're going to put them all in the array, and then for u spline component in the spline components, we're going to check, make sure this component isn't our component. So if component is not equal to spline component, and actually I typoed spline component up here, then we're going to add it to our other splines array. So this will give us an array of all the spline components in the world that are not the one that is currently being edited. And then now we want to actually do something with that. So first let's define our target distance. So target distance squared. And why don't we make this a member variable? So if we go to our header file, right below, or I guess right above, we'll do double snap distance equals, let's say 500. So this will be the world distance between the two spline points before it will be considered to snap it. So in this case, 500 centimeters. And we'll go back to our CPP file. And target distance squared is just going to be snap distance that we just defined times snap distance. And then we'll get a set int 32. And we want all the keys that are currently selected. So these are the indices of those spline points that are selected. And we'll set that equal to spline visualizer get selected keys. So the spline visualizer is what knows what is selected. And once again, we got that above. Then for each one of these, so for int 32 key and keys, we're going to get the current location. So f vector current location equals spline component. Oops. get location at spline point, and we'll give it that key index. And then we want it in world coordinates, so e spline coordinate space world. And then use spline component closest spline. So we want to find the closest one, so we'll make a variable for that. And it needs to be a pointer. Then we want to keep track of the index of that one, so closest spline index, and we'll just put that at -1 for now. And then we want to keep track of what the distance was, so the closest distance, and this is the square distance. And we'll set it to the numeric limits or double. So it'll start out at the max possible, so it'll always be less for the first one. And then use spline component, other spline in other splines. So for each other spline in the editor, or in the level, we're going to get all of its spline points. This is the O of n squared part I was talking about that will be slow if there's a ton of these. So I equals 0, I is less than other spline, get number of spline points, I plus, and then we're going to get that location. So f vector point location equals other spline, get location spline point, I in world coordinates, e spline coordinate space world. And we'll get the distance squared to that. So distance squared equals point location minus our selected point location dot size squared. And if that distance squared is less than the target distance squared, and it is also less than our closest distance, and we're going to update all of our bookkeeping here. So we're going to say closest spline is other spline. We're going to say closest spline index is I. And we're going to say closest distance is this distance squared. Okay, so this should find whatever the closest spline point is to the one that we have selected for each one of our selected ones. Then after this, or rather inside this for loop, we're going to say if the closest spline is not equal to null pointer, and we're going to snap it. So we'll first get the location, snap location equals closest spline, get location at spline point, closest spline index, e spline coordinate space world, and then spline component, set world location at spline point, and we're going to give it the key, and we're going to give it the snap location. So we find the closest one, and then we set the spline component's spot at that key to this location. And this for is so we do it for each of the selected keys, so you could theoretically select multiple spline points and it would snap to all of their corresponding closest locations. And that should be it, except for one typo here in get location, should be get location at spline point. And there we go, let's build and run. All right, we're back on our level here with our two splines. So you see I've got this point and I've got this point. If I hit Shift F, you see that that snaps perfectly onto the other spline. And so now I can just add spline points all I want to these two splines here. And if any one of them is close, I can snap it to any of the other ones. And if it's too far away, if I put over here, oops, if I get more than 500 away, you see it doesn't do anything until I get close enough, and then it'll snap to the nearest one. So there we go. Created a nice handy dandy snap to closest point tool here with a hotkey Shift F in our editor. And you can use this to do any kind of little tools you want to have hotkeyed in your editor, and it will work wherever you are. So thanks for watching. All of the code for this will be in the description at the Git repo link below. And if you found this video helpful, I'd appreciate if you liked and subscribed. Thanks a lot. Have a good one.